So we have a 6-pole induction motor excited by a 3-phase 60 Hz source. If the full load speed is 1140 RPMs, calculate the full load slip in RPM and as a percent. Okay, so we're asked to find slip in RPM and express as a percent. Remember what we said from class, that the idea is that slip is defined by industry given as a percent, and so this is the slip, and the slip in RPM is the relative speed, or we refer to that as the slip speed. Okay, so keep in mind now that we got a full load speed that's in, and we know that NS is greater than N. Okay, so let's think about what would we find on the nameplate for that machine. Well, we'd find N on the nameplate, and we'd probably find this on the nameplate. And remember that when is a 6-pole induction motor, that means that P is equal to 6. And, you know, it's not 6 by accident. I gave you 6 because it's divisible by 3. But you're not supposed to divide it by 3. You're supposed to know that P that fits in the equation is poles per phase, and that's how the number is generally given. And so if I don't say that 6 is the total poles, then you have to know that you're going to assume that's P, because that's how industry would interpret the piece of information that's given on the nameplate. So we want to calculate NS to start with. NS then is equal to 120 multiplied by the frequency and divided by P, the number of poles per phase. And so we have 120. Remember, that's simply a constant of proportionality. Multiply that by 60 Hertz and divide by 6 poles per phase. And we expect NS to be greater than that rated speed. And if we didn't get it, then we should go back and think about our calculation of what we have done. We also know that we expect the slip to be kind of small, and so, you know, if you've used 2 here and come up with 3600 RPM, and that gives you a huge slip, that should be an indication that you interpreted 6 incorrectly, right? And so be careful about stuff like that. Okay, so we're asked now to do 2 things with those numbers, and the first one is to figure out the slip speed. And the slip speed is, again, the relative speed or the difference between the 2 of them. And so simply NS minus N, and if we do it that way, of course, we'll have a unit of RPMs. And so we have 1200 subtract 1140. And so that gives us a slip speed let me fix that. Of 60 RPMs, and it's kind of important to think about the fact that this, you know, this does have a unit here. So the slip speed then 60 RPMs. So now if we're going to calculate the slip is usually S. That's supposed to be a lowercase s. NS minus N divided by, remember, it's a percent of NS, so NS on the bottom here, times 100%. And so we have the NS minus N now, right? 60. And the field speed on the, or sink speed on the bottom. And so if we do the division there, that gives us 0.05 or 5%. And remember that we said that that is, you know, a typical value for full load. Now, they won't all be 5%, but that one turns out to be exactly 5%.